if you are going inside the surface of the earth, inside the earth itself, and you want to find out the value of the acceleration due to gravity, well, how do we do that? So one thing you have to understand, the first and the very important concept is that the only sphere which is beneath this particular body will be only considered for giving the gravitational force. Okay, why we are not considering this part, you'll come to know, don't worry. So let's say the mass density of the earth is rho, and we will assume earth to be a uniform sphere. Okay, the mass will also assume it to be constant value and uniform. So we can say that the mass density is also constant, and density we have written, density is equal to mass times 4/3 pi r cube, which is the volume of the earth. Okay, where r is the radius of the earth, and the part that we are talking about, the radius is small r. No problem. Now let's say that at this point we are calling the value of acceleration due to gravity is g dash. What will be the mass of this part? Let's call the mass of this part as m dash, and mass of this part will be m, which is mass of the earth minus m dash. Correct? No problem. What will be mass of this part? M dash will be equal to density times volume, which is 4/3 pi small r cubed. No problem. Okay. Now you see, if you consider these two as two bodies, then I can definitely write the value of force, on this, the value of the gravitational force is going to be equal to g m dash times small m divided by small r squared, right? So I can directly write this force due to gravitation is equal to g m dash m upon small r squared, isn't it? Because you are going to experience the gravitational force only because of this, and we know that this is also equal to m times g dash. Correct? Okay. So let's take it further from here. Let's see how we solve this. So what all things we have got till now? We have written down the value of m dash, we have written down the value of m, and we know that the force of gravitation will be only because of this sphere which is beneath this particular ball or the object that you are considering. Why we are saying so? Because if you consider this particular sphere, take a chunk over here. Let's say there is a chunk over here. Okay, so this chunk of mass will be attracting the ball in which direction? In this direction. And diagonally opposite, if you take, or just radially opposite, diametrically opposite I should say, if you take this chunk, this mass will be attracting it in this direction, thus cancelling the effect of each other. So this is what happens. So if you can think of a point, each of these masses are attracting like this, so we are not considering it. And obviously when we deal with the field, the concept of field, that is the gravitational field inside a solid sphere, then even there will be more clarity about this concept. No problem. But now you can just understand that this is why we have only considered this small part of it, this part which is beneath this body. Okay, perfect. Now as we know this, all we are left with is to apply the formula and get to the result. What I can write, if the value is g dash over here, I can write m ge dash is equal to g times of m dash times small m divided by r square, where m dash is the mass of this part of this portion of the earth. Okay, now ge dash can be written as g m dash by r square. No problem. Okay, now this m dash, we can replace this in form of rho. Correct? So what we can write? ge dash is equal to g times of m dash can be written as rho times 4/3 pi r cube, and this divided by r square. Okay, what do you get? This goes. So you have ge dash is equal to g times rho 4/3 pi r. Okay, now this is something very important. Now when you look at this, you see acceleration due to gravity is directly proportional to the distance of the point from the center of the earth. Inside, right? So if I'm saying that this is r, this is nothing but a part, right? This is a part from the center of the earth, right? From, you are measuring this distance from the center of the earth to that part till where you are in, right? Okay, so as you can see, it is directly proportional, which means as you go on increasing, you will be accumulating more and more and more and more mass, and the value of this acceleration due to gravity should go on increasing. Okay, now a question comes, what if there is a body at the center of the earth? So now if you replace this r equals to 0, then the value of g dash will become equal to 0, which means if I talk about the weight of the body, it will be in a state of weightlessness. Did you understand this? Okay, so inside it is directly proportional. Inside it is directly proportional. But we want to refine this even further. Okay, we want to refine this and write it in terms of what you say, the formula that we are used to represent in, that is in terms of the acceleration due to gravity on the surface of the earth. To do that, can I write this rho, the value of rho, density of the earth, as me divided by 4 by 3 pi re cube? Yes, definitely. So we get, if I write rho equals to mass of the earth divided by 4 by 3 pi radius of the earth cubed, I can get g dash is equal to g times of rho can be written as 4 by 3 pi, sorry, rho can be written as me divided by 4 pi by 3 re cube, right? And then you'll have this value, that is 4 by 3 pi small r. Okay, now you see this 4 by 3 pi and 4 by 3 pi, that get, we'll be left with a simple expression that I'm going to write over here. The expression will be ge dash is equal to g times of me times r divided by re cube. This is what we have, right? This is what we have. Now, can I write this in form of acceleration due to gravity? Can this re cube be written as re square times re? Yes. And what is gme by re? What is this value? This is nothing but acceleration due to gravity on the surface of the earth. Correct? So I can rewrite this as, ge dash is equal to, let me write it over here. We can write this as ge dash is equal to ge times small r divided by re. Now, the value of acceleration due to gravity on the surface of the earth is constant. The radius of the earth is also constant. So from here, what do we get? Inside the earth, we have a direct proportionality. That is, ge dash is directly proportional to the value of r. ge dash is directly proportional to the value of r, where r we are measuring it from the center of the earth. No problem? Okay. So you see, again, a lot of information. So take it slowly. We can write mge dash is equal to gm dash m divided by r squared. I can cancel this off, right? You get to this expression. Then what I do, I can write m dash in form of rho and volume, right? So I have represented that. You know that this r square and this will get cancelled out, correct? So you'll be left only with r. From here itself, you can see that all these values are constant, isn't it? Right? So ge dash can be written as directly proportional to r. No problem. Okay. Now this re cubed can be written as re squared times r, right? Which means that this entire expression, that is ge dash is equal to g me by re squared times small r by re. This entire thing can be written as what? Acceleration due to gravity on the surface, that we are representing it by ge. So you can see now clearly that it is directly proportional. No problem. No problem. All right. Okay. So well, we have got to this particular point. But what about this r? If somebody wants us to express this in form of h, that is the depth from the surface of the earth, the depth that we have to represent. Then if you think about it, this total distance is RE, okay. This depth that we are talking about, or let me just draw it over here, this total distance is RE, this height is H, and this distance is what we are saying is equal to R. So what is the relation between small r, radius of the earth, and H? I can write small r is equal to RE minus H. Can I write this? Yes. If you replace this in this formula, what do we get? GE dash is equal to G ME, and this can be written as RE minus H divided by RE cubed. No problem? No problem? Okay. Let's take this R square outside and let's take one R inside. Okay. So what we are going to write is, we can represent this as R square divided by RE. If I take this RE inside, what will happen? See, this GME by RE squared can be written as G, so we can write GE dash is equal to GE times this will be RE by RE, so 1 minus H by RE. This is the final expression in terms of depth or H height below the surface of the earth. What will be the value of acceleration due to gravity? Okay, at H height, when you're going H depth to H depth. So don't get confused with H and D. Okay, in some books they have written it as D, in some books they write it as H. The meaning is simple, that when you go below the surface of the earth to a distance of H, then the expression of the acceleration due to gravity at that particular point will be given by this final expression. No problem. I want all of you to write it down very properly. These expressions are important, as you have seen that the questions in your NEET exam are directly based on these expressions, and if you're lucky enough, you might get a question on this as well.